Okay, we're looking at a mini test 31, question 3. So we've got a uniform beam, and we're told the mass of the beam. So obviously if it's uniform, that mass is going to be working halfway along the beam. It's resting on two supports, and we're told the distance of AC and DB, and I'm also showing them on the diagram. Okay, so let's sketch that out with all the various forces. So there will be reaction at C. It's actually not drawn to scale. A reaction at D. There's the actual weight of the rod. So the mass is 12 kilograms, so the weight is going to be 12g, and we know it's a uniform rod, so we know that's working halfway along it. Okay, so what else did it tell us? So when we place a mass at B, so if we're placing a mass of M, its weight will be mg. So when we place that at B, the beam is on the point of tipping about D. Okay, so what that means is it's about to start turning, and the support at D will be a pivot. So that end will start moving downwards, tilting downwards, and that end will start tilting upwards. So what's important for us is at that point, so when it's on the point of tipping, it is still touching at C, but the reaction force there is 0. So if we applied any more force to this end, this would start to lift off. Okay, so that does have a very specific meaning when we're working with moments. Okay, and then that really helps because it means that there's only 3 forces to consider. There's the force due to the mass of the beam, there's the force due to the mass that they've attached to the end, and then there's the reaction at D. So if I take moments about D, so obviously if I'm taking moments about D, then I don't need to use the force at D. I'm going to be able to find the value of M, hopefully. So if I'm taking moments about D, I need these distances from D. Well, that I was given in the question, that's 3 meters. The rod is uniform. So if the rod is 7 meters long, the center of mass is 3.5 meters from the end. So the distance I need is going to be 3.5, take away 3. So 0.5 meters. Okay, so then we're pretty much there. So I've got, so if D is my pivot, this sort of pulling down on the right-hand side of it is going to be trying to turn the whole thing clockwise. So that is going to be a force of mg times a distance of 3. I won't put 3m, I won't put 3 meters because otherwise I might get confused about my different m's. And then that must equal, because it's not actually tipping, it's just on the point of tipping, so that must equal the anti-clockwise moment, and that 12g, the mass pulling down to the left of D, is going to be causing an anti-clockwise moment, so that's going to be a force of 12g times a distance of 0.5 meters. So one thing I can do is cancel through by g, just makes it a little bit easier. And then so on the left-hand side, I've got 3m. On the right-hand side, I've got 12 times a half, so I've got 6. So m is going to be 6 divided by 3, so 2 kilograms. Job done.